This is the beginning of part 2 of our module on pricing credit default swaps. We remind you that this part 2 contains chapters 3 and 4 of the module, with chapter 3 describing the use of the CDS survival probability curve for any entity to calculate the fair value of a CDS contract in the secondary market, and Chapter 4, containing 4 quiz questions to test our understanding of these materials. This Chapter 3 teaches you to derive the implied survival probability of an entity from its CDS curve and to use this survival probability to calculate the fair value of a CDS contract after inception. A reference entity's survival probability is the flip side of the default probability coin. A reference entity that has, for example, a 6% default probability for year 1 would have a 94% probability of surviving past that year. When we come to longer periods, however, we need to proceed with a little caution. Take the case of the reference entity we discussed previously, for which PD1 came to 6%, while PD2 came to 7.41%, if you recall. It would be wrong to calculate the entity's probability of surviving past year 2 as simply 100 minus the sum of the PD1 and PD2, which would give you 86.59%. Because, as we explained previously, PD2 is a conditional probability. The correct approach requires that you first recognize that the probability of surviving past year 2 is nothing more than the probability of surviving year 1 and then also surviving year 2. Therefore, we need to multiply the probability of surviving year 1, hence the first parenthesis, by the probability of surviving year 2, assuming you have survived year 1, hence the use of the conditional default probability here of 741, and this multiplication gives us a survival probability for 2 years of 87.03%. Therefore a little higher than what the incorrect calculation immediately above would have yielded. We will restrict ourselves as before to talking about survival probabilities for an entire number of years, no fractions being allowed. And therefore we can introduce the notation SPK to denote the probability of surviving past year K, i.e. of not defaulting in year K or any prior year. Note that this is a cumulative concept, so that necessarily SP3, for example, would be larger than SP4, and more generally, as written at the end of this bullet point, SPI is always greater than SPI plus J for any positive values of I and J. If we now consider a CDS contract having a tenor of N years and priced at a spread, annualized of course, of SN as indicated here, the protection buyer, of course, would pay this SN annually up to and including the date, if any, on which a credit event occurs, i.e. for as long as the reference entity survives. Once again, we remind you, including the year at the end of which it defaults, if any. Therefore, the probability adjusted PV of the stream of cash flows made by the protection buyer can be written as the sum from I equals 1 to N of the spread times the probability of surviving long enough to pay that spread in each year times the discount factor that is applicable for that cash flow. Turning to the protection seller, that party makes a payment equal to 1 minus RV at the end of one single year only. And this 1 minus RV henceforth we will denote with the acronym LGD, which stands for loss given default. And the likelihood of that payment equals the specific probability calculated up front that the reference entity will experience a credit event at the end of that particular year. Therefore, the probability adjusted PV of the payments made by the protection seller can be written as the sum of this LGD amount times the probability that the reference entity in any given year will default at the end of that year, PDI, having survived all previous years, SPI-1, and finally multiplying all that by the discount factor appropriate for a cash flow occurring at that time. Note that this requires us to define what we even mean by SP0, since in both this formula and the previous formula, when I equals 1, the SP term would become SP0. Well, this is easy. Since we are defining SP1 to mean the probability that the reference entity will survive until the end of year 1, i.e. until the beginning of year 2, it follows that SP0 means the probability that the reference entity will survive until the beginning of year 1, which is obviously 100%. We next set these two quantities equal and move terms around to derive a general formula for PDN. The algebra is extremely tedious, but ultimately within the grasp of anyone with a first course in college math or even less. We will skip it here and simply provide the solution which has just appeared in front of you. We will shortly turn to worksheet general, where this formula has been programmed, but we first familiarize you with the term that we will use going forward, first sigma, by which we refer to the first summation appearing in this formula right here, and then the term second sigma, by which we refer to the second summation appearing towards the right of the numerator of this formula right here. Worksheet general is fairly self-explanatory and requires you to input for the reference entity in question the CDS spread curve in this row 5, where you may notice we have a number of columns hiding for purposes of space, and also the zero coupon risk-free curve in this row 6. From this, it will calculate for you in row 8 the default probability for any given year and the survival probability up to that year inclusive. Note, for example, that if we put the 1-year CDS at 3.6, as in the earlier example in this module, and the 2-year CDS at 4%, and finally if we put the recovery value at 40%, again as before, and the risk-free curve at 5%, which it already is here, the worksheet correctly derives an implied conditional default probability for year 2 of 741% and an implied survival probability through that year, remember this is a cumulative concept, of 87.03%, both exactly as we had done before. Given how critical it is to understand these two terms precisely, we repeat their definitions here. The 741 implied default probability for year 2 is the implied probability, implied from the CDS curve, that the reference entity will default at the end of year 2, assuming it has survived until the beginning of that year. And the 8703 implied survival probability for year 2, or through year 2 if you like, is the probability that the reference entity will survive past the end of that year. Note that we have set all risk-free rates at 5%. But of course you have the flexibility to input a curve of any real-life shape that you desire. Among the more interesting learning points that we can derive from this worksheet, please note the following. First, if we make the CDS curve flat at any level, for example, at the 3.6 that we have for year 1 and year 2, the conditional probabilities of default in each year become equal to one another. This should be intuitive, since by asking for no higher a spread for a longer tenor than for a shorter tenor, the market is implying that each year is equally risky on a marginal basis, as we explained before. Second, if we set the spread for any tenor at any particular level, for example, once again this 3.6%, but then we lower the recovery value to 30%, we would find the survival probability rising and vice versa. Again, this should be intuitive. Lowering the recovery value to 30%, of course, makes the overall risk worse, while keeping the CDS spread the same as before at 3.6 can only be explained if accompanying the lower recovery value expectation is a lower default probability expectation, hence a higher survival probability expectation. Third and last, for our present purposes, if for a particular reference entity its debt is very well secured and collateralized so that recovery value, for example, is 90%, very high level, then you will note that even a modest CDS spread would be consistent with pretty high default probabilities and low survival probabilities across the curve. To confirm this, we accompany the 90% recovery value that we have input already with a CDS spread of, shall we say, only 0.5% across all tenors. And despite this very low, or generally pretty low CDS spread, we find that the survival probabilities are actually pretty low as well, and that by year 10, the survival probability has shrunk to almost only 1/2. By the same token, it should be simple to observe and understand that if the CDS spread is very high, for example, 700 basis points for the 1-year contract, and then rising linearly by 25 basis points, shall we say, per annum. So you can see us typing in the formula equals the cell to my left plus 25 basis points, and now copying and pasting across all columns, including the hidden ones, so that we reach a CDS of 925 for the 10-year contract. Then the implied survival probabilities, even when the recovery value is normal, for example at 40%, the implied survival probabilities are very low indeed. An intuitive way of understanding this is simply to say, why on earth would the market need 700 basis points even for 1 year, and certainly higher for the subsequent years, other than the fact that the implied default probability is very high indeed, and therefore the survival probability is very low indeed. We now proceed to the revaluation of CDS contract. Assume you bought protection at 3% on a 5-year CDS, and very shortly thereafter find the CDS at 4% for that same maturity. You can now sell protection at this new higher spread and lock in a 100 basis point profit margin for as long as those two contracts remain outstanding. Note importantly that you have no principal at risk from a credit event, since you would collect from one side the same amount that you would lose on the other side if a credit event occurs and the two contracts are settled. Now, if this were a simple IRS, i.e. interest rate swap, you would regard your profit as the present value of an annuity for the 5-year remaining tenor, which would equal, note here, S5, which is the current CDS spread for a 5-year contract, or in our example 4%, minus the original rate of 3%. That's the size annually of the annuity profit. And of course, we must multiply each of those annuity cash flows by their respective discount factors and then sum the total. But since S5 minus 3% is already known from the moment of the calculation, we can take this parenthesis outside the summation, leaving us with the equation you see here on the right-hand side. However, a CDS revaluation does not work in this way. It works slightly differently, because unlike the case of an IRS, your annuity may not actually survive for the full 5 years, since it would terminate if and as soon as a credit event regarding the reference entity occurs. Stated another way, the annuity continues only for as long as the reference entity survives. Please note carefully, we're talking here about the reference entity survival, not that of the counterparty, which is an altogether different matter. So the above formula needs to be amended to reflect for each cash flow within the annuity the probability that the contract survives until that date, which is the same as the reference entity surviving until that date, leading us to the following formula. The mark-to-market from the unwind, or simply from the revaluation, is equal to the same as we had before, but note now the adjustment of each cash flow in the annuity by the survival probability of the contract and the reference entity until the date of such cash flow, SPI, and again multiplied by the discount factors. And the same algebraic logic as before enables us to remove the constant item S5 minus 3% and leaves everything after that to the right of the summation sign. More generally, we can write for the mark-to-market value or unwind value or termination value of a CDS contract having a remaining tenor of n years and an original fixed spread of CDS F as in fixed, that the mark-to-market is equal to, and you will see the very close analogy in this formula and the formula we had above, except for the use of more general algebraic terms. And once again we can take out the size of the annuity effectively, CDS current or new minus CDS original or fixed, and the rest remains after the summation sign. So we remind you here that CDSN stands for the current CDS spread for an n-year remaining tenor of the contract. Now, we have ignored, as is typical of swap revaluation, any risk of non-performance by the counterparty to the CDS contract. In reality, of course, some sort of credit reserve is usually set up by banks and brokers against the risk of non-performance by the counterparty, and especially on those contracts that have a positive mark-to-market in favor of the reporting party. Practitioners have adopted the expression risky DV01 to refer to the quantity you see here, which is everything including and after the summation sign in our previous formula. And this contrasts to the normal expression DV01 or PV01 or risk-free DV01, which represents only the summation of the discount factors, as you see here, without any weighting of those items by any survival probability. This latter item, of course, describes, in a sense, the price reaction of a fixed income instrument, swap or bond, or any of the sort, to a 1 basis point increase in the risk-free curve. Hence the terms risk-free DV01 versus, for our CDS, risky DV01. You should quickly be able to confirm to your satisfaction that for any given tenor, the risky DV01 is always less than the risk-free DV01, since the multiplication by the survival probabilities, items that are always less than 1, can only reduce the amount of the risky DV01, all other things, of course, being equal. It bears repeating that one of our assumptions here is that the accrued spread is paid by the protection buyer to the protection seller up to and including the date of the credit event, if any. We have previously mentioned that this convention does not always apply, depending on jurisdictions and reference entities in some cases. And therefore, if you are revaluing contract under which the accrued spread is not paid for that period up to the date of the credit event, if any, the formula becomes, for the mark-to-market, sigma, same as before everywhere, except you will note the item n at the top of the summation operator, the sigma, has now become n minus 1, meaning, of course, that this formula is the same as before except for the removal of one cash flow. Let's illustrate this with an example. You enter a 5-year CDS contract as seller of protection at 350 basis points, and 1 year later you wish to close your position when the entire CDS curve for this reference entity is flat at 425 basis points. The risk-free curve is still flat at 5%, and recovery value is still estimated to be 40%. What is your P&L? Click pause until you are ready to listen to the answer. First, you should recognize from the fact that you sold protection before the spread widened that your P&L will be negative, since to close your position you would need to buy protection at this wider spread of 425, and thereby you would incur a negative carry of 75 basis points annually. Now we go to this new worksheet labeled 4-year CDS revaluation, which is essentially identical to the previous one and also has a number of columns that have been hidden, except that we have also added a few items specifically for first sigma and second sigma, and this item down here that you see to reflect the formula for the mark-to-market that we discussed previously. We proceed to insert 40% as instructed for RV and recognize that the curve lies today not at 3% or any such number, but rather at 4.25%. And discover in cell D17, which has the mark-to-market of the contract, a loss of 2.4%, almost exactly, of the contract's notional amount. Note that if we were not adjusting for the survival probability in the formula, your loss would have been almost 2.66%. In this expression here, where the survival probability is left out completely, and the normal discount factors in row 7 of the risk-free curve are used instead of the more correct methodology we explained earlier of using those discount factors weighted by the survival probabilities, as in row 12. And therefore this result for the mark-to-market would have been 2.66% loss, and this would be designated as the riskless mark-to-market as a reference to the false assumption that there is no risk that the annuity might terminate prior to its final maturity. The fact that we weigh the cash flows of the annuity, whether for a gain or for a loss, by the survival probabilities means necessarily that the mark-to-market, the correct mark-to-market, in cell D17 will be smaller than the incorrectly calculated riskless mark-to-market of cell D18. This is a special characteristic of CDS contracts that makes them different in an important way from interest rate swaps, cross-currency swaps, and many other derivatives. This graph you see here plots the P&L, profit and loss, for a 5-year CDS contract against movements in the CDS spread in basis points from the perspective of a dealer selling protection at 300 basis points paid annually, and assuming the CDS curve for all tenors is always flat. The red line shows the correct mark-to-market valuation using correctly the risky curve to discount cash flows, while the blue line plots the results you would obtain if you inaccurately discounted cash flows at the risk-free curve. This brings us to the end of this chapter 3.